Hello all, welcome to the class of data structure. What is data structure? Data structure is nothing but the way to organize the data so that we can get the information out of it in a very efficient way in lesser time, and if we want to process it, that way should be efficient. So for that we must understand what is data. Data is nothing but the values with which we deal every day. Any values like 10, 99.60, A, Nagpur. We have identified different types of data and we name it as if if we are dealing with a digit, we call it as integer. If we are dealing with fraction values, we call it as float. If we are dealing with a single character, then we store that value as a character. And if we are dealing with the combination of character, then we call it as a string. We know how to store this data using any language. More specifically in C or C++, these are the basic data types: integer, float, and character. We also know that how we can store large number of data of same type, and the solution is array. Array is defined as a collection of homogeneous data element which is stored in sequential memory location, and we depict that array as boxes in continuous manner. We give this array a name and we identify every value of this array by the index like 0, 1, 2, 3, and so on. If the array is of type integer, we can store only integer values in this array. And if the array is of float, then we can store only float values in this array. If the array is of character, then we can store only character values in the array. So we can't mix two or three different data types together to store in an array. So if array is of any specific data type, we can store n number of data elements in an array, and which will be stored in sequential manner in a continuous memory location. So this is the basic way to store the multiple data, but but this way is inefficient when we are going to deal with heterogeneous data or large number of data. When you want to process large number of data, then array becomes a little inefficient. So first we must look where array is lacking. Suppose I have an array having only 3 elements. Now I want to insert a new element 35 where 15 is located. So it means I want to insert 35 at second location of an array. So if I directly put 35, then 15, we may lose the data, we may lose the 15, and because it will get overlapped. So what we have to do, we have to shift the element to the right. So what we need to do, we need to shift 99 to its right, 15 to its right, and now there is a room, there is a space for 35. So to insert an element in an array, what we are actually doing, we are shifting the values to the right. In an array, if you want to delete an element, so in the same way, suppose I want to delete 10, which is stored at first location, then I'm going to shift 99 to the first so that 10 will get overlap, then 15. But this is the most inefficient way of dealing with the data, because imagine we have an array of 1 lakh element, and if I want to delete any element which is located at second location or third location, then we need to perform that much of shifting operation just to insert or delete a data. So we are not spending time on insertion or deletion operation, but rather we are spending time on shifting the data to store it correctly. Another operation which we have seen on array is searching the element in an array. Suppose I have an array with 6 or 7 elements, and if I want to search whether 25 is present in this array or not, then I need to go and visit each value sequentially. So I go on checking whether 25 is equals to 10, no, then next element, till I get the element, or if till I reach at the end of the array. So now I got the element 25 at the location 4. And last operation which we are familiar with is sorting. We can sort the array. Okay. For that we have many sorting algorithms, but I think all of you are aware of bubble sort algorithm. What bubble sort algorithm do is they basically compare two elements, adjacent elements, and if the rightmost element is having less value, then we get it shifted to the left. So these are the basic operation which we can perform on an array, that is inserting, deleting, searching and sorting. Among these, inserting and deleting takes a lot of energy if we are going to insert the element at the middle, or if we are going to delete the element from the middle, because we need to spend a lot of time on shifting operation. So this is, although array is a good data structure, but there are some more better data structure which we are going to learn in this semester. So what is data structure? I'm again going to repeat, is data structure is nothing but the way we can organize the data, the way we can store the data. It is a more logical model so that we can retrieve the data back in lesser time. We can perform all of these operations like inserting, deleting, searching, sorting in a more quicker way and more efficient way. So in this semester we are going to deal with two basic types of data structure, that is, first is linear data structure and another is non-linear data structure. Array is an example of linear data structure. What does it mean by linear data structure? Linear means if we are processing the data one by one sequentially, if we are storing the data one by one sequentially, then that type of data structure is called as linear data structure. In this linear data structure, we are going to concentrate on three basic data structures like linked list, stack and queue. And in non-linear data structure, we have trees and graph. Linked list looks like this. Here you can see there are individual units in which the value is stored. First unit we have stored 10, in second unit 20, in third unit 15. These individual units are known as nodes of the linked list. So if you can see, the half of the unit is storing the data and half of the unit is actually blank, but it is not actually blank, it is holding address of another element, another node. So this is, first unit is holding the data and another unit is holding the pointer or the address of the next node. We are definitely going to repeat this topic in next lecture, but just to get an idea how linked list looks like. So now this is the example of linked list. Another data structure is stack. uh, Stack is nothing but an array, but having some restrictions on how it should operate, how it should insert the data and how it should delete the data. In an array we can insert the data in the middle, in the start, at the end, anywhere. But in case of stack, although it is an array, we have imposed some restrictions that you can insert or delete the data from the top of the stack. So whichever the data is inserted will be inserted at top, and the data which we need to delete will be deleted from top. That is the last location, last element we insert will get processed first. So it is also known as first in last out data structure. Uh, Definitely we are going to go deep in this stack in second unit. Another data structure is queue. I think many of you are, I think all of you are aware about what is queue. Every day we go, say in admission procedure, we get in queue. Wherever we go, in bus stand we get in queue. So what is queue? Whoever first comes first will get processed first. So this is another data structure which is sequential, which is linear, and which is implemented using the help of array. You can see this is simple array, but having some restrictions on how we can insert and delete the data. So we can define queue as an array in which, or as an a data structure in which we can insert an element at one end and delete the element from another end. The front and rear is nothing but the location where we can insert or delete the element. Front indicates the location from where we can process or we can delete the data, and rear indicates the location where we can insert new elements. Another data structure is tree. Uh, Tree is a hierarchical way of storing the data. So there is a root and then subtrees and subtrees and subtrees, that are branches of the data. There are many situations where we need to store the data in this hierarchical way. And last one is graph. Graph is a way in which a node can point to the multiple nodes. A node can point to not only two nodes but multiple nodes. Just to quote an example, all of you might be aware, if I want to go to multiple cities, what I do, I draw a graph. So, and I try to get the connectivity to all the cities which I need to visit, and then I chalk out my tour accordingly. So graph is a data structure which we use in daily life, but we need to understand all this data structure, how we can implement this data structure in computer science using C or C++. So this is overall gist what we are going to learn in this third semester data structure syllabus. Some of these, as I said, stack, queues, trees and graph are the example of our routine life. So I would like to quote some example. Concept of stack as a data structure in routine life. Um, you must have seen this. These are nothing but the disk keep kept at one above. If I want to remove the disk which is placed at middle, what I need to do, I need to first remove the plate which is at the top, and then the plate which is at the second location. If I try in this way, now this is incorrect way because it will all collapse. So we can't process the data which is at middle. What we have to do, we have to process the data which is at top. So what we need to understand, although this diagram is very simple, we need to understand how this concept can be implemented in programming for the better and efficient way of storing the data. Another concept of queue, as I said, if I am traveling to another city and I am on a toll booth, so the vehicle which comes first will get the token first, vehicle which come later will get the token later. So first vehicle will get the token first. No one can overtake in this queue. So if at all it happens, then it is incorrect. So this is the general way of behaving, and now we need to implement this as a data structure. Just to quote a simplest and an example on a lighter note, a tree, we can we always store the data in such a way. Director, under the director we have two engineers, and under engineers every engineer has a labor. So this is hierarchical way of storing. Another example is which we are familiar with, the family tree. So that's all for this lecture. We are going to meet in second lecture, in which we are going to concentrate more on linked list. We will be learning how we can create a linked list, how we can create a node, how we can create a linked list, how we can process, which type of operation which we can perform on linked list. Till then, study this well, and you can ask me questions on these topics anytime, anywhere.